So a point moves in the plane xy coordinate system according to this law: x equal to at, y equal to 8 into 1 minus alpha t, and alpha are positive constants. Equation of the point's trajectory is to be found. Of course, plot. Okay, velocity v and acceleration w as a function of time, the magnitudes basically, and the moment t naught at which the velocity vector forms an angle of pi by 4 with the acceleration vector. Okay, fine. This is very similar to problem 1.24. So we take part A. So we know x is equal to at. This means t is equal to x divided by a. Now we know y is equal to at times 1 minus alpha t. Now substitute t in terms of x. That gives me a into x by a into 1 minus alpha t is x by a. A cancels out. This gives me, so this means y is equal to x minus alpha x square by a. That's it. Right. Is equal to x minus alpha x square by a. So that is the first part. Now for the second part, velocity and the acceleration magnitude have to be found. So first of all, let's find out the x for velocity. Let's find out the x and the y components. So vx is nothing but dx by dt, right, which is at, this is a, right, and vy is dy by dt, right. So y in terms of t is 18 to 1 minus alpha t, just differentiated with respect to time. D by dt of 18 to 1 minus alpha t. Okay, right. A is anyways a constant, so a comes out, and you can apply the product rule. So first I'll differentiate t and keep 1 minus alpha t as it is, and then I'll keep t as it is and differentiate 1 minus alpha t with respect to t. It'll give me minus alpha. So right, so this becomes a alpha t. Okay, so minus 2 alpha a t, right. So the v magnitude will be root over vx square plus vy square, right, which will give me root over a square plus a minus 2 alpha a t ka whole square, right. So if we take a out, we can take a out, right, because you can take a square out from within the square root, so outside the square root it becomes a, so it becomes a times root over 1 plus 1 minus 2 alpha t plus 1 minus 2 alpha t whole square. This is your v. Got your v, right. You got your v. Now for the acceleration, let's again find out. Let's represent it by w1. So wx is dvx by dt, right. So vx, as you already know, is a constant, so then it becomes 0, right. And wy is dvy by dt, which is basically d by dt of, sorry, let me write it more clearly, which is nothing but d by dt of vy is a minus 2 alpha at. So this is a constant first term, second term is just some constant multiplied by t, So when you differentiate it, it just constant by which it was multiplied, which is minus 2 alpha a. So obviously w again is root over wx square plus w y square. Wx was 0, wy was minus 2 alpha a, right? So this gives me w magnitude is equal to 2 alpha. So which is a constant, of course. The alpha and a are both constants. Okay, so now you need to find out in the C part the time at which the velocity and the acceleration vectors are at an angle of pi by 4. Now let's plot the directions. So let's say this is your coordinate space x, y. Okay, let's start with the easy one. So for w, we already know there is only a single negative y. I mean the y axis, the basically it in the along the y-axis, uh, it has a negative component of minus 2 alpha a, right? And in the x-axis the component is 0, right? So let's draw that with red. So this is your w vector, right? Simple. Acha, what about the velocity vector? Velocity vx is a constant and vy is a minus 2 alpha at. Vx is a constant, okay. Vx is some constant. Vy, okay. Now see, you need an angle of pi by 4. So the y, if the y component of velocity is positive, then there would be an obtuse angle because it would lie in the first quadrant. This is the first, this is the second, this is the third, this is the fourth, right? So it has to lie either in the first or the fourth quadrant. Now if it is an angle of pi by 4 which is acute, it needs to be in the fourth quadrant, which means the Vy must be negative, which means the y component rather must be negative, right? And this will give you V. So basically speaking, if this angle has to be pi by 4, and we know that tan pi by 4 is 1, and what is, okay, now let's talk in terms of the magnitudes. So this is obviously Vx, right? Okay, and since Vy is actually negative, the magnitude of the y component would be actually minus Vy, right? So this would actually become, right, so pi by 4. So basically it's the height, which is Vx by the base, which is minus Vy. So Vx is equal to minus Vy, right? Now Vx, okay, Vx is a, right? Vx is a, Vy is a minus 2 alpha at. A minus 2 alpha at का negative, right? This means a is equal to minus a plus 2 alpha at. This means 2 alpha at is equal to 2a. So a cancels out, 2 cancels out. Since the time at which the angle between the acceleration and the velocity vector is pi by 4 is 1 by alpha. So okay, so did they, just a minute, the moment t naught. So okay, so basically this is your t naught, the desired t naught that you want, where the acceleration and the velocity vectors are at an angle of pi by 4 or 45 degrees to each other. So yeah, that's that. Thank you.